The robot is powered by solar energy and navigates by GPS. The FarmBot is a CNC machine for plant beds. It will automatically grow plants for you. The FarmBot starts by planting seeds and knows which type of plant is planted in each location. It can then water each one based on its type and age. It can detect and pick out weeds as well as monitor things like soil moisture. No coding is required. The software helps you lay out the optimal plant bed, mixing different types. And the advanced version can automatically switch between tools for different jobs such as seeding, weeding, watering, and soil monitoring. NASA is even looking into how the FarmBot could be used to farm food in space, on the Moon, and on Mars. This is the milking robot called Astronaut by Lilly Vector. It is designed to minimize stress for the cows and reduce the human workload. The cows approach the robot by themselves when they are ready to be milked. The machine recognizes each individual cow from the sensor on their collar, so the milking process can be adjusted according to personalized historical data, and brushes autonomously clean the udders. Iron Ox has created entire year-round hydroponic farms that are run by robots. These indoor farms can produce about 30 acres worth of food on just a single acre of land. The farm is run by two robots. One moves trays of plants around, and the second has a robotic arm for manipulation tasks such as seeding and transplanting. The robots also use machine learning and AI to detect pests and diseases, removing plants before they infect others. The Energid fruit harvesting robot uses a frog tongue mechanism to pick fruit. A grid of tongues is moved past a tree on the back of a tractor. When the camera system notices that a tongue is lined up with a fruit, it shoots out and grabs it, just like a frog catching a fly. Virgo is a high-speed automatic picking robot. It can pick any type of crops from tomatoes and strawberries to cucumbers, and Virgo is able to select and pick only the ripe ones. This picking robot by Root AI runs on a track and is able to work in dense greenhouse environments and can work day and night. CNH Industrial have created an autonomous tractor. It works in a field spraying, planting, and harvesting. This driverless tractor can be hooked up to a farm's existing equipment for autonomous plowing or spraying. And it can keep working 24 hours a day, making the most of yearly seasons. Harvest Automation have created the HV100S robot. These robots are used to move and arrange plant pots in commercial growing facilities, such as a large nursery, and they can also gather the plants for seasonal protection. The $10,000 Burrow robot helps farm workers by transporting equipment and crops around the field. It allows farms to pick and pack up to 30% more. The robot can carry up to 500 pounds or 225 kilograms. It uses computer vision and high-precision GPS to follow workers around the field or move crops from the field to truck autonomously.
Leonardo da Vinci created a mechanical knight capable of imitating human movements, such as sitting and standing, moving their hands, neck, and lifting the visor of the helmet, just to prove that there was no one inside. The following functional robots were created in 1774 by the Swiss watchmaker Pierre-Jacques Drauz. 3 automated dolls, a musician, writer, and artist, still work in the Museum of Art and History in Neuchâtel. The Genoid robot plays the organ by flipping the keys with his fingers and imitating breathing. One robot child draws 4 images, and the other writes text up to 40 characters long. In the 1800s, Japanese master Hisashigi Tanaka, who laid the foundations of the future Toshiba Corporation, created many extremely complex mechanical toys. Even if they were not full-fledged robots, they were much more complicated than the first British robot. But that was not all. In 1970, the first digitally controlled anthropomorphic robot, Wabot-1, was created at Waseda University in Tokyo. The second version of the robot, introduced in 1980, was able to play the piano. Wabot-2 was able to take a person, read notes, and play melodies of medium complexity. Wabot was the first in-fact predecessor of Osmo, presented in 2000, and for a long time remained the most perfect humanoid robot in the world. Developed by Honda, the robot was able to recognize objects, gestures, sounds, and faces to talk and interact with people as well. Capable of autonomous navigation, Osmo was created to become a multifunctional mobile assistant. The last version of Osmo was introduced in 2014, but as of today, the project is now closed. With the advent of the 21st century, began a real boom in robotics, including the creation of humanoid robots. In 2002, Sony introduced the Sony Dream Robot, which was able to walk on the stairs, bypass obstacles, and get up when falling. In 2003, engineers from the Technical University of Munich assembled the robot Johnny. The key skill of Johnny was to have a fast, dynamic, with a stable, human-like gait. A year later, the University of Osaka presented the robot Actroid with realistic silicone skin. The robot is able to recognize and process speech, answer questions, and respond to touch. For the study of human and robot communications, in 2005, the company Engineered Arts created RoboThespian. The robot is able to use expressions and gestures to communicate all emotions. The developers positioned this robot as an actor, promoter, and entertainer, or potentially a teacher. In 2006, Adelbaron Robotics in France introduced an autonomous, programmable, human-like robot, NAO, with open-source code, which became a research platform for schools and institutes. In 2009, Boston Dynamics presented its own robot, Petman, which became the precursor of the Atlas robot. But this is a completely separate story. We will tell you about all the developments of Boston Dynamics in detail in the issue by clicking on the link from the video card. At the same time, the Italian Institute of Technology introduced the iCub open-source robot to explore the possibilities of artificial intelligence as well as any other experiments with robots in general. In 2014, the robot Aiko Chihira from Toshiba got a job. It was created to work at the information stand in the Tokyo shopping center, where it helps customers to navigate in the store. The robot has no special abilities, but can talk in Japanese and sign language as well as imitate human movements. That same year, the South Korean robot DRC Huba won DARPA's Robotics Challenge. It did best with driving, opening doors, climbing stairs, and even drilling holes. And all this for a tasty price of $2 million. But the biggest breakthrough in 2015 was the robot Sophia, brought by company Hanson Robotics. Sophia has become almost legendary. She was attributed to a developed intellect. She still travels around the world and runs her own social networks. We've previously covered Sophia, and if you want to know all about her, check the link in the video card above. The breakthrough of 2016 was the first robot with tactile feedback. The underwater bot Ocean One transmit the sensation of objects back to the operator so it can lift fragile vases from shipwrecks from the ocean floor. The robot is equipped with bimanual arms, stereoscopic vision, and 8 control motors with sensors. In 2017, it was demonstrated by the first useful humanoid robot Talos from PAL Robotics, capable of not only exploring the surface, like many other devices, but also to perform precise and complex tasks. Then there was the amazing robot builder, Mega Advanced Robots, Telepresence, and other incredible humanoid and inhumanoid robots.
The manipulators are a separate topic. Here, we will look at the most interesting and unusual robots from the exhibition. It can also transport crops harvested by farmers in the fields. The robot can stream video from its cameras in its head. Movement is provided in 2 modes: direct control by a human sitting on top, and remote control by remote control. At the same time, the robot also relies on data from sensors, such as the gyroscope, mounted on the robot to generate stepping movements. In addition, the robot monitors the position of the entire body and will not fall if suddenly struck to the side, for example, or if its foot hits an unstable surface. Itself, as well as its friend, which is called Friends. In the future, according to the company's vision, these robots will support people in hazardous jobs, as well as care for the sick and elderly. Kaleido is the strongest and most agile of the robots. It can, or will in the future, get to the scene of an accident, clear the debris, and retrieve people from under it, which can be recognized even in a pile of gravel. The robot is 179 centimeters tall and weighs 83 kilograms, which should give it a range of motion like an adult male, but limits its actions in small and narrow spaces. Although Kaleido was suspended at the exhibition, the developers assure that the robot is exceptionally strong and not afraid of falls. Kawasaki Heavy Industries also introduced its autonomous service robot Nioki, which is capable of moving and working in an unstructured human environment. It is safe for humans, can open regular doors, and easily handle boxes in a warehouse or trays in a restaurant. The robot is equipped with a LiDAR and vision sensor to create a map of the environment, understand its place in it, and notice everything going on around it. Nioki can also be switched to remote control if the robot gets confused or an error occurs. It is possible to teach the robot new skills by remote control. It simply remembers the movements the operator gave it. To move, the robot uses a system of AMR, Autonomous Mobile Robot, which allows Nioki to determine the route to a given target. Metacoroid, founded as a joint venture between Kawasaki Heavy Industries and medical electronics manufacturer Sysmex, brought its Hinatori surgical robot to the exhibition. The robot received regulatory approval last August and is positioned as Japan's first robotic surgical system. It has no narrow specialization and can perform a wide range of operations, thanks to its precision and large number of degrees of freedom. Human Machinery Company gave a demonstration at the show of its very impressive general-purpose robot working in conjunction with an aerial work platform. The humanoid robot is remotely controlled and provides the operator with feedback for grip strength control. The machine is equipped with powerful electric actuators that provide it with strength coupled with high-precision movements. The robot is designed to maintain railroads and other transportation systems and works exclusively in tandem with the operator. According to the developers, it allows not only to save jobs for people, but also to increase their wages by improving their skills, as well as to protect workers during operation with heavy elements, at height and not only. It is worth noting that the idea is not new. We have already seen something similar, though on a smaller scale, from Sarcos Robotics, which is developing the Guardian XT robot based on its own Guardian Exo exoskeleton. The main announcement of the exhibition was the humanoid collaborative robot Next Stage Philly. This is a continuation of the Next Stage line, which has long been actively implemented in industrial enterprises in Japan. The robot, according to the company, embodies practicality and Kawanda's 3 concepts of development: compact size, matching price to performance, and design with high proximity to human. Philly is designed not only for enterprises, but also for other applications, such as the hospitality industry and the like. However, so far the robot's abilities at the reception desk are not impressive, even though it looks quite dexterous in production. However, so far the robot's abilities at the reception desk are not impressive, even though it looks quite dexterous in production. Philly's price on the Japanese market will be just over $50,000.
Idéntico a un ser humano. Se trata del primer conductor de noticias virtual y reiteramos, se presentaba en un video de 30 segundos, se presenta además este robot a sí mismo y según los expertos su uso reduce costos y mejora la eficiencia, según se ha explicado además durante la presentación como parte de la 5ª Conferencia Mundial de Internet que comenzaba durante esta misma semana en la República Popular China.